Think about the raw power of the ocean, those endless waves crashing against the shore. It's truly awesome, isn't it?
It really is.
And it makes you wonder about all the energy locked up in that constant motion.
Well, yeah. And here's a staggering thought. Wave energy could potentially meet something like 10% of our planet's entire electricity needs.
10%. Wow. Let that sink in for a
It's,
moment.
it's immense. And what's particularly interesting, I think, is its reliability compared to, say, solar or wind.
Right. The sun has its cycle, wind can be intermittent.
Exactly. But the ocean, it's almost always moving. That predictability is a huge part of why there's such a buzz around wave energy right now.
Definitely. And that brings us neatly to what we're diving deep into today. CorPower Ocean.
Ah, yes, CorPower.
Their story is fascinating, and their tech seems like a really innovative way to, capture that wave power.
It really does.
So our mission today is to explore how they got started, the clever engineering they're using, and where they fit in the bigger picture of wave energy globally.
And by the time we're done, you'll see why a lot of experts are convinced that tapping into ocean waves could be a real game changer for climate change, for clean energy access.
Sounds good. Okay, so every breakthrough starts somewhere. And CorPower Ocean's origin story is, well, pretty unique.
It really is.
It all began with a cardiologist, Dr. Stig Lundbeck, back in 2009.
Yeah, a heart doctor. He had this insight, apparently, about mimicking the human heart's pumping efficiency for wave energy.
Exactly. The heart is incredibly efficient.
Amazingly so. And Dr. Lundbeck's core idea was that the rhythm of the waves could be harnessed using a similar principle, a device that could sort of pump energy from that continuous motion.
Right. So fast forward to 2012, Dr. Lundbeck teams up with Patrick Miller, a tech entrepreneur.
And they founded CorPower Ocean in Stockholm. They got some crucial early backing, too, from European InnoEnergy.
And their driving vision was clear from the start, a sustainable future powered by the oceans.
It's a great mission statement. And it highlights that blend of medical science, business acumen, and, an environmental drive.
It really does. Patrick Muller actually mentioned it was specifically the pumping motion of the human heart that inspired their compact, resilient design. That biomimicry aspect is fascinating.
It is. Looking across different fields often sparks the most original ideas in renewables. Nature's already solved a lot of these problems.
Okay, so we have this heart-inspired concept. How do they actually grab that energy from the waves? What's the tech?
Well, their main technology uses what's called a point absorber. Basically, imagine a buoy floating on the surface.
Just bobbing up and down with the waves?
Pretty much. But the real cleverness is inside. They've developed this internal system, sometimes described like a spring in a gearbox.
Inspired by heart mechanics, right?
Exactly. So as the buoy moves up and down, that motion gets converted into mechanical energy. Think of it like compressing that spring, and then that drives a generator. Makes electricity.
Okay, but here's where it gets really interesting, I think. It's not just passive floating. They talk about phase control. What's that about?
Phase control. That's key. It's how the buoy actively tunes itself to the rhythm of the incoming waves, at least in normal conditions.
Tunes itself.
Yeah, think of pushing a swing. If you time your pushes just right, matching its natural swing, you make it go much higher, right?
Right, more energy.
Precisely.
Yeah.
The CorPower buoy does something similar. It adjusts its response to each wave to maximize the energy it captures. It syncs up with the ocean's pulse.
That makes perfect sense. It's all about timing. Okay, but what happens when things get rough? Big storms, huge waves.
Good question. That's where their storm protection system is vital. Instead of fighting those massive forces, the device can actually detune itself.
Detune.
Yeah, it basically becomes kind of transparent to the really big waves. It relaxes, lets them pass over without taking the full force.
Ah, like how wind turbines feather their blades in high winds.
Exactly like that. It's about survival first in those extreme conditions. You have to be able to ride out the storm.
That's incredibly smart. Okay, so their main device now is the C4. It's pretty big.
Yeah, the full-scale one is about 19 meters tall, 9 meters across. It's that distinctive yellow buoy design.
And inside is the wave spring mechanism control software. It's tethered to the seabed.
Right, tethered down, and the up and down motion drives that cascade gearbox and the generator inside.
And the efficiency claim is pretty bold, 5 times more electricity per ton than older designs.
That's what they state, yeah. Thanks to that heart-inspired tuning and the lightweight structure. It's a significant claim if it holds up at scale.
So it's like a smart buoy with a built-in shock absorber and amplifier.
That's a good way to put it. It catches waves optimally, but loosens up when things get really rough.
And the plan isn't just single buoys, but core packs, clusters of them.
Exactly. Clusters of maybe 20, 30 units, aiming for around 10 megawatts total, comparable to a big offshore wind turbine.
Like a school of small buoys instead of one giant tower.
Yeah, that distributed approach might offer benefits for resilience, maybe less visual impact too.
Now, getting from a clever idea to a working device in the ocean, that's a huge leap. Can you walk us through their testing journey?
Sure, it was very methodical. Started with bench tests, simulations, then progressively larger prototypes in the sea.
Step by step.
Right. A really key moment was back in 2018. They tested their half-scale C3 device up in Orkney, Scotland at the EMX facility.
EMAX, yeah, the big marine energy test center.
That C3 device, about 25 kilowatt, survived months in the North Atlantic. That was huge validation for the core concept, really proved it could work in tough conditions.
Must have been a massive confidence boost. And then they scaled up to the full C4 system for the Highway 5 project in Portugal.
Yes, they moved to the Agusadura site off Portugal, interestingly, where the old Pulimus wave snake was tested years ago.
Right.
By 2020, they'd laid the subsea cables, and then the big milestone came in late 2023, deploying the first commercial-scale C4 device.
The big yellow one we talked about?
That's the one. And in October 2023, it was connected to Portugal's grid, started feeding power.
And the early results sound good. I saw something about peak outputs hitting 600 kilowatts.
Yeah, initial performance has been strong. That 600 kilowatt peak is impressive. For a device rated at 300 kilowatts, shows that phase control boosting power capture, and they think upgrades could push it towards 850 kilowatts.
Wow. But maybe even more important was surviving that big storm, Storm Domingos.
Oh, absolutely critical. November 2023. That storm threw 18.5-meter waves at it that's over 60 feet.
Incredible.
And the C4 rode it out. As Patrick Muller said, wave energy has huge potential, but designs must survive these extremes. Surviving a once-in-a-decade storm, as they called it, was massive proof for their core tech.
Absolutely essential for long-term confidence and, insurability. So what's the next step for CorPower?
Deploying a cluster.
Huh.
The plan is to put several devices together, including their next-gen C5 buoys, to form a pilot wave farm.
Within the next year or two.
That's the goal. It's crucial for proving the economics at scale and getting third-party certification. They aim to launch a certified commercial product by the mid-2020s.
And they're scaling up manufacturing in Portugal.
Yeah, they've got a plant in Viana do Castelo and have raised significant investment, over $95 million by 2025 is the target, I think. The vision is clearly global exporter status.
Sounds like they're really hitting that commercialization phase. Okay, stepping back, why does all this progress in wave energy matter so much for our energy future?
Well, it adds a really valuable piece to the renewable puzzle. One key strength is consistency, predictability.
Compared to solar and wind, you mean?
Right. Waves are basically stored wind energy, and they keep rolling 24/7. Big swells last long after the wind dies down. So it offers potential as a more reliable, almost baseload renewable source.
Ah, interesting. Helping balance the grid.
Exactly. Patrick Miller talks about it providing a stable production profile, potentially helping replace traditional baseload like coal or even nuclear.
And you mentioned complementarity. How does it work with solar and wind?
Yeah, it often peaks at different times. Wave energy might be stronger in winter when solar is lower, for instance, or it continues after storm winds drop off.
So it fills the gaps.
Pretty much. CorPower uses the phrase, wave energy helps plug the voids of wind and solar. Makes the whole renewable system more robust, more dependable.
That makes a lot of sense. And what about energy density? I've heard water packs more punch than air.
Oh, massively more. Water is about 800 times denser than air. So even relatively small waves carry significant energy compared to wind.
Meaning smaller devices for the same power.
Potentially, yes. Or more power from a given sea area compared to, say, a land-based solar farm. Good for places with lots of coast, but maybe limited land.
And the sheer scale of the resource is mind-boggling, isn't it? Tens of thousands of terawatt hours per year potentially available.
It's vast.
Yeah.
Truly vast. One industry report estimated maybe 350 gigawatts of wave and tidal capacity by 2050. And Ina Braverman from Eco Wave Power even made a bold claim.
What was that?
That theoretically, waves could produce maybe twice the world's current electricity consumption. That's extremely ambitious, but it shows the scale people are thinking about.
Wow. And there's an equity angle too, right? So many people live near coasts.
Precisely. Over 40% of the global population, Many coastal communities, especially remote islands or in developing regions, rely on expensive, dirty diesel.
So wave power could be a local clean source for them.
Exactly. Indigenous energy. Imagine a small wave farm transforming a remote community. And the resources everywhere, Pacific Islands, Africa, Europe, the Americas. It supports a fair energy transition globally.
And fundamentally, every kilowatt hour from waves is one less from fossil fuels.
That's the bottom line, direct climate mitigation. Plus, it's zero pollution during operation and often quieter, especially the submerged devices. It's a major tool, as Mueller says, to address climate change and end fossil fuel dependency.
Okay, the potential is clear, but it hasn't been easy. We touched on storms. What are the big challenges the sector still faces?
Yeah, the ocean's just a tough place to work. Survivability is paramount. Those extreme forces, saltwater corrosion, currents, marine growth, it's a hostile environment.
Designing something that makes power and survives rogue waves.
It's a huge engineering challenge. We saw early devices fail. That's why things like CorPower's storm tuning or Oscilla Power's submersible design are so important. They learn those lessons.
And I guess the costs are still high initially.
Very much so. Like
Yeah.
early offshore wind, building prototypes, specialized deployment vessels, tricky maintenance at sea. It all adds up right now.
But the hope is costs come down with scale.
That's the trajectory, yes. More energy per device, mass manufacturing. But it needs that initial investment, supportive policies, grants, maybe carbon pricing to get there.
And the technology itself is still evolving, not one standard design yet.
Right. It's a younger field than solar or wind. Yeah. You've got point absorbers like CorPower, oscillating water columns, overtopping devices, seabed pressure systems, lots of different ideas.
Does that diversity help or hinder?
Bit of both, maybe. Spreads the effort, but also spurs innovation. We still need more long-term testing to see which designs are most reliable and cost-effective, including all the bits, power takeoff, moorings, anchors.
And what about environmental or social aspects, interacting with marine life, fishing, shipping?
All needs careful management, environmental impact assessments, coexistence with other ocean users, visual impact, permits, public acceptance. It's all part of the process.
But potentially fewer not in my backyard issues than, say, onshore wind.
Possibly. Wave farms are often less visible. No noise above water, no emissions. But community engagement is still absolutely key. People need to understand it.
So challenges remain, but it feels like the industry, companies like CorPower, are actively tackling them.
Definitely. Survivability is being proven, costs are starting a downward trend thanks to better efficiency, and the tech is maturing through testing and collaborations like Wave Energy Scotland pooling knowledge.
You mentioned the parallel with offshore wind earlier.
Yeah, it feels very similar. Offshore wind faced huge hurdles early on, but look at it now. Wave energy seems poised at that same inflection point, moving from experimental to potentially commercial scale this decade. Continued innovation, funding, political will, they're crucial.
It's exciting to see. And CorPower isn't alone, right? You mentioned a rising tide of innovators.
Absolutely. It's not just one horse in this race. Take EcoWave Power, for instance, based in Israel and Sweden.
Their approach is different, isn't it, onshore?
Totally different. They attach floaters to existing structures, piers, breakwaters. The wave motion moves the floaters, drives hydraulic pistons, and the generator is actually on land.
Advantages. Easier maintenance.
You got it. Easier access, plus they can lift the whole system out of the water in really bad storms. They had that grid-connected array in Gibraltar for years, now moved to LA, and they're building a megawatt-scale project in Porto, Portugal.
Interesting. Leveraging existing infrastructure. What about Carnegie Clean Energy in Australia, their CEO system?
That one's fully submerged. A buoy oscillates underwater, driving a pump. High-pressure fluid goes via a pipe to an onshore turbine.
So invisible from shore and protected from surface waves.
Exactly. They've tested off Western Australia, planning a next-gen unit in Spain. They're even looking at remote communities like in Alaska, and the potential for desalination producing fresh water, too.
Clean energy and fresh water. Cool. And Oscilla Power in the U.S. Triton.
Yeah, their Triton is a two-body point absorber, a surface float connected by tethers to a submerged ring.
Two bodies.
Right. It allows it to capture energy from more directions of motion, up, down, side to side, etc. Multi-mode capture, they call it. More power potential.
And storm survival.
Clever trick there, too. The whole thing can automatically submerge deeper to avoid the worst wave crests. They tested a scale model off Maine recently, aiming for a full 1 milliW device.
Wow, the engineering is just incredible across the board. And we should probably acknowledge the earlier pioneers, too, like Pelemis.
Definitely. Pelemis, Aquamarine. They didn't reach commercial success, but the lessons learned were invaluable. Today's companies benefit hugely from that experience. Plus, better materials, smarter controls.
And more support infrastructure now. Test centers like EME.
Yeah, and government programs too, like the US DOE's Powering the Blue Economy or EU funding. It's creating a better ecosystem for development.
So lots of different approaches, maybe different solutions for different places.
Exactly. It's not likely to be a one-size-fits-all technology.
Yeah.
But the key thing is, multiple companies are hitting significant milestones now. It does feel a bit like the early days of aviation. Lots of experimentation leading toward viable designs.
Okay, so as we wrap up this deep dive on core power and wave energy, it really feels like we're at a significant moment, doesn't it?
I think so. A real turning point.
Huh?
Wave energy is shifting from just promising but tricky to something genuinely on the horizon. Companies like CorPower are showing it can be done efficient power generation and surviving the ocean.
It's pretty inspiring, using the ocean's own rhythm for clean power. Speaks volumes about human ingenuity tackling climate change.
And that global equity aspect is so important too.
Yeah.
Clean, reliable power for coastal communities everywhere, reducing fossil fuel reliance in vulnerable spots. It's a global effort.
Absolutely. So for you listening, as this wave of innovation keeps building, what can you do?
Well, stay informed, follow renewable energy news, support policies that fund R&D and demonstration projects for things like wave energy.
And if you live near the coast.
Get involved in local discussions if marine energy projects are proposed. And just spread the word, let people know about the potential here. Awareness helps build momentum.
It definitely points towards a future with a richer mix of renewables, including the oceans. It feels optimistic. Patrick Muller's vision, a sustainable future powered by the oceans.
It seems increasingly within reach. Wave power is a crucial piece of that complex energy transition puzzle. Still unfolding, but the potential is just immense.
Indeed. And on that note, here's our final thought for you to consider. Could waves quietly power our future?
We'd love to hear what you think about that. Or if you have ideas for our next deep dive.